Good morning, students. So, any doubt in the yesterday's class? Why it is coming like this? We are here, just adapt now. You tried, you taken print, check, taken photo, huh? Yes, yes. While projection also, I think lens full screen is not coming, small. I think okay, leave. So in yesterday's class, we were discussing about the secondary storage devices. We started with the various types of secondary storage devices. So your second unit is based on disk storage and basic file structures. So how we are storing the data in the disk. And because we deal with the database, no? So database, usually in olden days, they were storing the data. The database tables are stored in various secondary storage spaces. Because they have a large amount of data. They were using large amount of data, so during that time, the memory is costly one, and most of the computers are with less memory space. They have only RAM also very less, and hard disk also capacity also very less. If you see the old computers, say the Pentium computers or Pentium 123, the memory is maximum say 1 GB. The RAM will be maximum 8 GB or 4 GB RAM. They will add extra slots, SDD slots they will add for additional memory. So the memory was costly 10 to 15 years before. So the file storage and the disk storage, memory plays an important role. Time and memory plays an important role. So in your database management system, we are studying the topics like disk storage and file structures. What are the different file structures where we can store our data? So here we are going to discuss the topics like introduction to file storage and disk, then buffering of blocks. You might have heard buffers. Buffer means it is also memory where we can store the data, temporary memory storage. I think you might have studied different types of memories: buffer memory, temporary memory, virtual memory. Nowadays we are using cloud. So it means it's a place, temporary memory space. Placing file records on disk. So once you create some table where we can store our data properly, because once you store the data, we need some technique to retrieve the data. Storing is also important. Storing it permanently is also important. The same way retrieving the data is so storing the data and again retrieving the data from the stored memory place for future reference is also places an important role. So placing file records on disk and retrieving the data is an important topic. So with that topic also we're going to discuss, and the various file operations what we can perform. Say storing the data, reading the data, updating the data, modifying the data, seeking the data, seeking for particular data. All those things places an important role. So we'll discuss about the various file operations. Then files of unordered records. So if your file is not in ordered form, so if it is not indexed properly, and how we can make use of the heap file storage. So it means we'll use hash functions or we'll use the heap Heap means you might have heard binary tree. So what is the difference between binary tree and the heap structure? So there is a minor difference. So it will look like an, we can from the binary tree, B plus tree, we can go for heap. So it means in a ordered form, so that we can easily access through the hash function, we can easily access the data. So heap storage is an important topic, like hash functions for accessing, storing, and retrieving the data. The same way, heap files also places an important role for random access. And files of ordered records. If your data is in an ordered form with a sequence of numbers or indexing, then if it is in the sorted form, A to Z or 1 to 100 like that, so it is easy to access through the index number. So these are the concepts we are going to discuss with respect to the file storage. Then we discussed the storage hierarchy. So in storage hierarchy, we know the different types of secondary storage devices like primary storage. We discuss about the RAM. Within RAM itself, we have static RAM and dynamic RAM. Static RAM is very high speed. Dynamic RAM is used for storing the during the processing time. In static RAM only the passwords, your operating system data, all those things will be stored. Then we discussed the territory storage. So it deals with the portable types of secondary storage devices like optical disk CDs, CD-ROMs, read-only memories, digital DVDs, digital versatile disk, readable DVD, read-once DVD, read-write DVDs. Like that, we have different varieties of DVD. Then we discussed the memory hierarchy and storage devices. So the primary storage level, we have static RAM and dynamic RAM. Static RAM is used along within, it's available within the CPU. And my main memory is called dynamic RAM. It is low cost, versatile, and low speed compared to static RAM. And if you take the secondary storage, territory storage, we used magnetic disk, CDs, DVDs, all those things. Then we discussed the flash drive, or we will call it as USBs, where it is a portable one, small in size. It can nowadays it's available in 32 GB, 128 GB like that. So it is easy to carry. And if we have two types of flash memories, NAND and NOR flash, based on the type of logic circuits. I think you might have studied AND or NOT. AND means logical multiplication is called AND, logical addition is called OR. NOT is complementary, and the combination of NOT and AND is called NAND. Just the complement of AND is called NAND gate, and NOR gate is complement of OR gate. So if both the inputs are 0, then only the output will be 0 in case of OR. If any one input is 1, the output will be 1 in case of OR, because it is logical addition. But in case of AND, this logical multiplication, if any one input is 0, then the total output will be 0 only. And the flash drives also used in cameras, MP3s, MP4 players, cell phones, as well as PDAs, personal digital assistants. So, and the NAND flash drives high storage capacity of 8 GB to 64 GB. So the flash drives or pen drives are based on the concept of NAND. So where the NAND gates will be used to store the data. And in most of the mobile phones, MP3 players, MP4 players, and PDs, flash drives, we are using they are all secondary storage device where we can store the songs or videos and other things. 100% of GB slower than the magnetic disk, less cost, more storage capacity. So if you take the flash drives, the memory is cost is less, and the speed of magnetic disk is high speed memory device, but flash drives are low cost and low storage. They can store more data, but the speed is very less. And if you take the magnetic tape used for archiving and backup storage of data. So if you have a large amount of data, especially in mainframe computers, as well as in core banking, where they are using SAP, PeopleSoft, there they will have customers throughout the world. So they need to maintain backups, they need to maintain other they, they will go for the data warehousing. So there and all they are using, still they are using the magnetic tapes. Tape jukeboxes and up to contain bank of tapes that can be automatically loaded into the tape devices, becoming popular in territory storage to hold terabytes of data. So magnetic discs are very high in capacity. The speed also very high. It's mostly used in the business sector, share market, and most of the trading centers, IBM mainframe softwares, and PeopleSoft, and most of the LMS systems, they are all using magnetic tapes. Then we, up to this, I think we discussed in the previous class. Here, this particular table gives you an idea to compare the various types of memories based on the type, capacity, access time, maximum bandwidth, and price of the product. So if you take the main memory RAM, it is always costly, and the memory space will be based on the size of the memory. The cost will automatically increase, and the access time is very high speed, because it is available within the CPU microprocessor, CPU itself. And maximum bandwidth is 35 GB per second. And it can access and process the data in nanoseconds. And the cost will be from $100 to $20,000. Compared to all other memories still till date, the RAM cost is very high. Based on the RAM cost only, mobile phones, even the players, laptops, tabs, whatever may be the brand of the product, the cost is fixed based on the RAM capacity. And if you take the flash memory, SSD, nowadays SSD, many of the laptops are coming with SSD. What is that SSD? Solid state devices. So SSD is compared to the CPU, compared to the hard disk, SSD speed is very high, and that can stand life also very good. So nowadays most of the computers, laptops are coming with SSD memory. So it is called flash memory. The memory capacity ranges from 64 GB to 1 terabyte. And here the accessing speed, processing time it takes to retrieve and store back is 50 microseconds. Nanoseconds means 10 to the power of 9. Microsecond means 10 to the power of 3. There is a micro 6. Okay, micro is 6. Millisecond is 3. Okay. So the same way, if you take the flash memory, USB stack. So in a flash memory, we have two types. SSD is mostly used in mobile phones as well as in laptops. And flash memory, USB stick, memory stick is that what we are using, memory USB port. That is, we have two types. So the processing, here also the processing time is 100 microseconds. And the cost is less when compared to the SSD. So here it will take from $2 to $200. The magnetic disk processing speed is microseconds. My magnetic disk can store large amount of data. So the storage starts from 400 GB to 8 terabytes. And the cost is $70 to $500. So the same way we have optical storage like CDs and magnetic tapes and other kind of memory storage. So these are all, other than the main memory, all are secondary storage devices. Okay, only the main memory RAM is primary storage. The remaining SSD, USB stack, magnetic disk, magnetic tape, optical disk, CDs, everything is secondary storage. It means that it is not part of the microprocessor. Then if you take the storage organization of databases, most databases are stored permanently on magnetic disk, secondary storage for following reasons. So if you store your data, files, databases in magnetic disk, it is permanent. So if you save your data in table, it is permanent. If you're not saving your data in files or in tables, once you come out from the program, the data will not be available. So if you're writing a C program or Java program or Python program, you are giving some input, you are seeing the output on the monitor. If you just come out from the program, the data input and output will not be saved. So if you create files in your program, or if you use database backend in your program, then only the data will be stored permanently. So the same way, once you store some data in the files as well as in the tables, you need to store the data. It will be available in primary memory or in your C drive or D drive. So after a long time, you can transfer it to some secondary storage device also. Say, for example, if you are downloading an MP3 song, you can choose the option. The downloads can be stored in your primary memory, RAM, or it can be stored in your memory card, SD card. So the same way, whilst doing any processing, you cannot save all your tables and files data long time in main memory. That will waste your cost, time, efficiency, everything. So you need to store, choose an memory place where secondary memory storage, where we can store the data very fast, access the data fast. So the best option is magnetic disk because it provides 500 GB to 1 terabyte and cost also minimal, and it can be saved for long time. And it's having so many options to storing, seeking, accessing, retrieving the data. Permanent loss of storage data arises less frequently for disk secondary storage devices. So even pen drives, flash memory, sometimes it will not work. It may get affected by virus. Even memory also sometimes getting affected. So, but if you go for disk storage, that is magnetic disk storage, the volatile, the nature of getting affected by viruses, losing of data, and because it is in storage, it's like a very strong storage device. We can preserve the data without any virus and other malwares for long time. The cost of the storage per unit data is less for disk secondary storage for primary storage. If you store your data in primary storage, RAM, it will slow down your processing. So only the basic operations, the main version of your operating system, important programs, the programs which you cannot store in a transfer to secondary storage can alone be stored in primary storage because the cost and usage of memory, primary memory is very costly compared to the disk storage. So the magnetic disk storage devices places an important role while storing, retrieving, and organizing the large amount of data. Then if you take the SSD are used as alternative for magnetic disk. So compared to the next level is SSD. The first priority goes to magnetic disk. Second place is for SSD. Databases may therefore reside at different levels of the memory hierarchy. Magnetic tapes used for backing up database because of less cost. So the magnetic disk first place, second place the SSD memory devices. Then the magnetic tapes places in third row place, and the disk are online devices that can be accessed directly as anytime. So the same way, so the hierarchy of preference based on the cost, time, storage, volatile nature, and based on the various parameters, they categorized primary storage, RAM. Second place is for magnetic disk. Third place is for SSD. Fourth place is for magnetic tapes. And the fifth place for other secondary storage devices. So you take the primary file organizations. So once you save your data in files, what are the operations, basic operations which we can perform on files means the heap file. So it is mainly used for unordered data. If your data is in unordered form, so there should be some key or hashtag, or there should be some method to access. Say if the students are sitting in the classroom as per the order, 1, 2, 3 order, during exam time, the students will be sitting as per their roll number. So as per the attendance, the first student name will be in the first place. So it means that we can check whether which student is absent. If the fourth place bench is desk is free, means the particular student is absent. But if the students are sitting in unordered form, it is not easy to identify. So we need some unique ID or some index or some hashtag. We are using hashtag now. If you click on the hashtag, it goes to the all references. The same way, or we need some key, primary key or secondary key, or we are using the address. We will calculate the virtual address as well as the physical address. So one of the best method for accessing unordered files, unindexed file is heap access. The second one is for sequential files that will be in ordered form. Sequential means what? 1, 2, 3 in sequential form. It will be in the ordered form. If it is in ordered sorted form, we can go for different methods. The same way, hash files will have some hash function. You will give the value for the hash key. We'll find out, get some value. The address is the place where the data is saved. Okay, so like postal code. A particular postal code will refer to a particular person. Or if you take the vehicle registration number, through the registration number, we can get the complete detail about the person who is driving the vehicle. So it is like hash file is like it is the notation where we can compute the entire data. We can identify the access the data address where it is stored. And the same way B trees. So B trees, what is the concept? Binary trees. Yeah, the root node will be less. Left side will have greater values. Right side will have left nodes will be less than the root node, and the right subtrees will be greater than the left subtree. So like that we have some constraints. So based on the constraint, if you go in a pre-order traversal, we'll get the complete order. Say if your data is stored in B tree form, so in B trees it's having its own structure. So the root node will be greater than the left node and less than the right node. So if you go in pre-order traversal, left, root, right, then you will get the sequence. So 1, 2, 3 you will get. So like that we can easily, once you store the data, heap data structure. Heap data structure, because here we are discussing about how the in B trees and heap structure. No. If you store here, heap files means they are storing the data. It is in unordered form. The data itself it's in unordered form, and we are storing the data in heap structure so that we can make the form. So we have minimum heap, maximum heap. I think you might have studied in data structure. What is the minimum heap? What is the constraint? Yeah, I think the root node will be the minimum node, and in maximum heap, the root node will be. So the data is in unordered form, but while storing, we are following the heap structure. So through the concept, the data we can identify this by in the particular list of data. If the particular data is highest data, then it will be in the root node. And if the data is a particular data, so if you apply the value on the particular formula, you will come to know where it is stored. So like hash table, heap is also a formula where we can retrieve the address, physical address where the data is stored. But if it is sequential, anyhow the data, it is in the array form. So anyhow it will be in the ordered form. 1, 2, 3 we can make use. Sorted file means we are using the sorted file, we are storing the sorted form. So if the value is 1, the corresponding index will be 1, or the array may start from index 0. So just if you increment, we can reach the next one. The same way for secondary organization of auxiliary access structures allows efficient access to file records based on alternate fields than those that have been used for primary file organization. So along with the primary key to access the data, we will make use of another alternative key also, where through which we can access the data. So the next concept is called buffering of blocks, used in main memory to speed up the transfer from disk to main memory. So we know very well the buffers are used in between secondary ROM to RAM. So the data will be available in the ROM, main program will be available in the ROM. Once you compile your program, you will create the object code. So the object code will be in the form of move A, B, add A, add C, like that it will be in the object code, microprocessor code form. So in that context, we need to store the value of A, B, C in a particular memory place. So the initial values will be stored in the buffer. While performing the actual process, A plus B, the data will be transferred to the registers in the main memory. Say the accumulator will take the A value and the B register will take the B value. Both the values will be added by the arithmetic and logic unit. Again, the result will be stored in the accumulator. Once the processing is over, the accumulator will transfer the data back to the buffer. From buffer, the data will be transferred to the secondary storage device. So the buffer is a memory place. So it is less speed compared to main memory, high speed compared to the secondary memory. So for that purpose only we are using the buffers. So double buffer CPU can start processing a block once its transfer to main memory is completed. At the same time, the disk input output processor can be reading and transferring the next block into the different buffer. So in double buffering, if you are using double buffering or parallel processing or pipeline processing, in that case, the secondary storage will have the data that will be transferred to the buffer. The actual processing will happen in the main memory, and the data will be transferred back to the buffer. Then it will be transferred back to the corresponding secondary storage device. It permits continuous reading or writing of data on consecutive disk blocks, which eliminate the seek time and rotational delay. So what do you mean by seek time? I think you might have studied in operating system. Seek time. That is going and accessing and doing the process. Say if you are calling and if you are uploading some data in the Facebook or something, so it takes some time to upload. Or if you are calling them, it takes some time to connect. So when you are placing the request, when you are getting the reply. So the time delay, maybe if your computer or system is very fast, it will within a second it will be processed. If you are using low configuration, it will take 1 minute or 2 minutes. The same way, if you are trying to access some network, so based on the number of users, based on the network coverage, it will take some time to connect. So that is called seek time. And the rotational delay means if there is no network, no, we are not in traveling, so there is some disturbance, so it will take some time to get connected. So here they are giving you an picture of interface concurrency versus parallel execution. So here parallel execution of operations C and D and intermediate concurrency of operations A and B. So we are placing the operation A, and it takes some time to go to the processing. Then say here we are taking an operation in interrelated concurrency versus parallel execution. So in case of it is like pipeline processing. So the value of A is placed in the processor like fetching, then it goes to execution. Then when the A operation is in execution, the B operation comes into pipeline. Then once A is completed, then B is placed for processing. But in case of parallel processing, both A and B will, two concurrent processes will execute the process. Here it shows the disk blocks, input, output, fill A, fill B. So the number of instructions executed, the seconds. Say if you take the I value, I is the second, the time it takes to execute a particular process. During the first second, A value is stored. And the second I plus 1, the value of B is loaded. And the third second, fill A is happening. The disk blocks for processing, it process the A, then it process B, then it process A, again it process B. So use of two buffers A and B for reading the disk. So how the reading and writing is happening in the disk storage means it's based on the technology what we are using. If you are using the disk processing, parallelly it will process A and B. The same way, if you go for disk block input output read process, so initially it will read A, then it will read B, then it will go for the next again A. So parallelly we are doing more than one process. Say for example in your laptop, if you are opening, if you open the Word file, PDF file, one image, one YouTube video, one email is opened. So any window you can go parallelly.
So in that time, everything will be active. Once you go to the like multiple inheritance, I think you might have studied in Java, threads. So the threads will be created. So every thread will be active in your Windows operating system. So if you are going to a particular YouTube, then it will start playing. Once if overlapping is not enabled, if you come out from YouTube, if you go to the Word file or if you go to some Zoom video player or audio player, that will be stopped. The next process will start. So at a time, in case of audio video, if you come out from the YouTube, that will stop. Even in your mobile also, if you're watching a YouTube video, if you go to WhatsApp message, YouTube will stop. But if you are playing in music, if you are watching a text message in WhatsApp, the music will play. But if you start playing a WhatsApp video, the music will stop. Music player will stop. So at a time, one device can be, sometimes if you are attending a Zoom class, if you are getting a call, Zoom will overlap, and you call also, you can able to call. Sometimes the Zoom will cut for audio, audio will be cut for some time. You can attend only the call. You go back to Zoom, that will continue. So that is how we are making the settings, how we are making the multiple windows to work. So in the settings, if you give overlapping option, even in your mobile also you can see, if you enable overlapping, or if you enable the notification based on the, so all those things will come into this multiple buffering and dual processing, core processing concept. So how this buffer management is happening means, what is the time now? 9? Okay, we have another 10 minutes. Yesterday also complete, it was in the complete power only. So if you take the power management, buffer management, the buffer manager use the available main memory storage as a buffer pool. So it means that the available memory, buffer memory taken will be taken as a pool. Pool means we have multiple choice. You can pick anything. So if you go, there is a basket with n number of products. You can pick any product based on your choice. So which has a collection of pages. So here the memory, buffer memory will be available, and the primary memory is used for processing, and your data will be available in the secondary storage. So the secondary storage data can be put into the buffer as a pool of memory space, and you can pick any data, and that can be used for processing. The size of the shared buffer pool is controlled by the DBS. So database administrators can control which data can be stored in buffer, which data cannot be stored. We can give the priority. And there are two kinds of buffer managers. So the first one is one controls the main memory directly as the most DBMS. So if you take the relational database management systems, the memory, main memory will directly control, will give the rights, because whatever available in the buffer can be transferred to main memory for processing. So the main memory will restrict which data will come into the buffer. As per that, say if you want to go and meet any VIP, there will be some secretary. So the secretary or personal PA, he is like buffer. So if he allows, then only you can go on. If he gives appointment, then only you can, because the VIP or someone, say for example, you are going to meet a minister. So he will be having personal secretary. So all his appointments will be fixed by the secretary only. So even if you have the appointment, clear appointment also, if the secretary says the person didn't come, even if you are waiting on outside also, you cannot meet the person, because the VIP will not come and check whether you are sitting outside or not. And whatever call you make to the person, that will be taken, that will be accessed by the secretary only. So here the buffer is an person who controls the main memory. So the main memory has to give access rights to the buffer, and the buffer, according to the access rights, the buffer will take the data from the secondary storage. So that is one type. The second one allocates buffers in virtual memory. So virtual memory means you can say your memory capacity is only 8 GB, or if your memory capacity is only 1 TB. In virtual memory, if you go now, you can store 2 TB of data also. So it is just imaginary memory space, just you will create in the logical form. Physically, the memory will not be available. Logically, we can store huge amount of data, and based on the logic, data will be available. But cloud is logical as well as physical. But virtual means only logical, which allows the control of transfer to operating system. The operating system in turn controls. So through the operating system, we are creating the virtual memory space. You might have studied physical memory and logical memory, that is virtual memory allocation. And which buffers are actually in main memory and which one are on disk under the control of operating system most commonly used. So if you physically use the buffer, what data you can store will be controlled by the main memory. But if you go for virtual memory, we can store huge amount of data that is created and controlled by the operating system, what we are using. So any doubt with respect to buffer management? Buffer memory is a memory in between main memory to the secondary memory. Whatever data we want to process, that data will go to the secondary storage to the buffer. Then the actual data will be loaded in the RAM for processing. Again, the data will be transferred back to buffer to the secondary storage. And in buffer itself, we have two types. One is physical buffer. Which data we can store in the physical buffer memory space is controlled by the main memory. But if you go for buffer of virtual memory concept, we can store huge amount of data. That is depending upon the operating system, what we are using. It may be Windows or Unix or Linux or iOS. Depending upon the operating system, what we are using, we can create the virtual memory space. So that is about buffer management. I think you might have studied all those things in operating system, data structures, even in first year organization, introduction to computer organization also you might have studied. All put together, they are giving in with respect to database management system. So I think the introduction to principles of problem solving, so also you might have studied the storage, basic, same memory concept, hierarchy of memories, accessing speed, types of memories, the same way operating systems, hierarchy, priority of the memories, all those things. So the goal of using buffer manager is to maximize the probability that the requested page is found in the main memory. So through the buffer, because whatever we are transferring to main memory, that will go to secondary memory to buffer to main memory. So the wastage, waiting time, processing time of main memory is avoided. See, why the VIPs are having a personal secretary means, if they are directly involved, their time, energy, everything will be wasted. So their time and is very costly compared to the PAs or the secretaries. So the secretaries, they will schedule and they will allow as per the order. So the same way we are using the buffer memory so that we can avoid the usage and wastage of time of main memory. In case of reading a new disk block from disk, to find a page or to replace, that will cause the least harm to the sense that it will not be required shortly again. So based on the need, so buffer will check whether the data what we are transferring to main memory is necessary or not, whether it is going to be used immediately or not. So because based on the object code only, the next instruction, the program counter will take care of what is the next instruction which is to be executed. So that's what in RAM we have program counter, flag registers, zero flag, sign flag. So many flag registers we have. So many other registers also supporting the main memory, so that the priority can be made and the sequence of actions can be completed as per the order, so that the wastage, say you might have in operating system, you'll have deadlocks, seek time, all those things. So that that will be avoided. All those concepts, buffer concept is introduced in main memory to avoid, to sequence the process, to increase the speed, efficiency, cost, everything. In case of reading a new disk block, so if you want to read an you already stored in data in a disk block. So from the block of data, we are going to read. So say for example, it's like reading a particular page in the memory space. So you will take the block of data That data may be in immediate use of the main memory or not. So randomly we cannot go and read any data. So if the next data to be processed by the main memory is that particular block, that data alone, say in a block of, say we have n number of blocks, 100 blocks. We cannot read all the 100 blocks that will base to the main memory. As well as buffer memory also, time and the memory will be wasted. So the buffer, what it will do, it will check which is the next instruction to be used by the main processor. Say only we need the 10th block. That is the actual data we need for processing. So only the 10th block alone can be accessed, and that will be transferred to the main memory, where the 10th block is in need for processing, actual processing. So that unnecessary data will be entering into the main memory can be avoided. Replay here what they are telling, to find a page to replace that will cause the least harm in the sense that will not be required shortly again. So say, I think you might have studied the operating system to avoid the accessing time, seek time, to improve the efficiency, throughput, save some files while cleaning or checking for virus in your mobile. It will show these are the files not used for more than 1 month. You want to delete. These are the large files available in your memory. You want to delete. Or these are the say it will show, it will give you the priority. So if a particular app is not used for 6 months, junk files, temporary files, if you while cleaning your mobile or laptop, it will list out junk files, temporary files, least used files, and unused files, unused apps, duplicated files, duplicated videos. So that duplication can be eliminated, unused can be eliminated. So that we are that is occupying memory space, that is slowing your processor, that is creating harm to a no need for having multiple files, same photo 10 times, no, not necessary. So that you can delete. The same way temporary files you can delete, and unnecessary blocks, say the what is that, your notifications, as well as unnecessary whatever you feel unused. So that's what in operating system you might have seen least frequently used page replacement policy, or on what basis we are choosing a particular operation. Least recently used cyclic use to avoid the deadlock, to avoid if you've gone through the operating system efficiency, throughput, all those things, to avoid the deadlock, as well as to avoid the slow down process. We will be using all those techniques, page replacement policies, duplications, all those things. So all those things are taken care by the buffer. So we will say the temporary files are in buffers only, as well as say other nowadays we are getting so many say the user. So if I am seeing a particular type of video, it will give you the ads with respect to that. If I am searching for a new mobile, it will new mobiles released will come into, so the users statistics, so the social our behavior will be recorded accordingly. The billboards will come into picture. So billboards are nothing but they will scan our nature, age, cost, everything. Accordingly, based on our interest, it will show the recent arrivals. So that will motivate customer statistics. Buying nature will be analyzed. So you go through the concepts. I think I will upload it, or I will upload the module 2, unit 2. You just go through the content, whatever we discussed so far. So if you have any doubt, you'll ask me in the next class. Okay, all of you mention your attendance in the chat box.
Unit 1 PPT, can you please send them?
What?
Unit 1 PPT or material?
No, unit 1 PPT I already uploaded, no?
Okay, thank you.
Classroom I already uploaded. Bridge course, TLEB, 2 textbook, 1 reference book, and I think assignment It's in the PPT, unit 1 PPT itself. You can find the assignment 1. I think assignment 1 or once again I will check it out. I think uploaded last week itself, because it's deals with DBMS, RDBMS, OO DBMS, OR DBMS. I will check it out. If it's not uploaded, I will once again upload. I think, and one more thing, we have two Google Classroom, one based on Jain University, one more Google Classroom with a personal ID. So I don't know in which I uploaded. I will check it out. Okay, all of you mention your attendance in the chat box. So you go through the PPTs. If you have, I will upload today, unit module 2 also. If you have any doubt, ask me in the next class. Do you have any doubt clarification class for Saturdays? No. So on or no? That is on or off? Off. No power is no power there. Okay, those who answered can leave the class. Varun V, Amina Begum, Jayadirtha, Halini Mandava, Prakash, Santosh Kumar, yes.
Gehrke sir was present.
Okay, mention your attendance. Yeah,
And
mention your.
Amina Begum is present.
Okay, Sheikh Hina, Shur Anil Sai, Harshavardhan, Vishnu Reddy, Vijayan, Mani Manasa, Akif, Arvind Gowda, Shail Biswal, Rahul Kumar Shah, Jayant K, Shashank Jha, Olivia, Shadvi Korth, Santosh Raj, Nitish Singh, Tanveer. Okay, all of you mention your attendance. Those who gave attendance can leave the class. Okay, all of you are Shadvi. Answer to your attendance. Nitish Singh. Jayant. Okay, I will end the class.